We know very little about the species that live down there. We know very little about the distribution of the biological communities. We don't know how these animals have adapted to living under this unbelievable pressure that exists down there.
At 36,000 feet below the surface, in a place where sunlight never reaches and the pressure could crush a submarine, scientists have uncovered a discovery that could rewrite everything we thought we knew about our oceans. The Mariana Trench has long been the final frontier of Earth's unexplored depths. But what was just found at its deepest point is unlike anything humanity has seen before. Prepare to descend into the abyss and witness a revelation that challenges the limits of life, science, and our understanding of the planet itself. Let's find out. Journey to Earth's deepest point. Far below the surface of the Pacific Ocean lies one of the most mysterious and extreme places on our planet, the Mariana Trench, stretching nearly 11,000 meters, or about 36,000 feet. This trench sits east of the Philippines and plunges deeper than Mount Everest is tall. For centuries, the existence of such an abyss was only guessed at, but modern technology has revealed it as the deepest known point of Earth's oceans. To venture into this underworld is to leave behind everything familiar about life at the surface. The conditions within the trench are unlike anything we experience on land. Sunlight never penetrates those depths, leaving the waters in a state of permanent darkness. The temperature drops to freezing levels, chilling the environment to the point where only highly adapted organisms can endure it. The pressure is perhaps the most intimidating factor of all. At the bottom, it reaches hundreds of times stronger than what we feel at sea level. To put it into perspective, if a human attempted to descend without protection, the crushing force would end life instantly. Only specialized submarines, engineered with thick walls and reinforced hulls, can survive long enough to allow humans to glimpse the trench. To understand the journey downward, it helps to break the ocean into zones, each with its own conditions and inhabitants. The first is the photic zone, stretching from the surface to about 200 meters deep. Here, sunlight pours through the water, creating an environment where plants, coral reefs, and schools of colorful fish thrive. This zone is warm, bright, and filled with activity. Most of what people picture when they imagine the ocean belongs to this upper world, which supports much of marine biodiversity. Beneath it lies the twilight zone, extending from 200 meters down to about 1,000 meters. The light fades quickly in this layer, casting everything in dim blue shadows. The pressure here is already 10 times greater than at the surface, and temperatures grow colder. Life must adapt in unusual ways. Long, ribbon-like oarfish glide through the gloom, while fragile sea angels drift with delicate, wing-like fins. Creatures of the twilight zone often have large eyes to catch the last traces of sunlight or reflective bodies to blend with the darkening waters. Below this begins the midnight zone, a realm where sunlight never reaches. This mysterious region starts around 1,000 meters deep and stretches downward into near-complete darkness. The only illumination comes from the creatures themselves, glowing through bioluminescence. Lanternfish, anglerfish, and other deep-sea dwellers use these eerie lights to lure prey, confuse predators, or attract mates. Among the most astonishing residents is the Magnapina squid, with arms that can stretch up to 6 meters, flowing like delicate ribbons through the inky blackness. Another unusual inhabitant is the blobfish, whose jelly-like body allows it to endure the crushing pressure of this deep environment. Going even deeper, we enter the abyss, starting around 4,000 meters below the surface. Here, the water hovers just above freezing, and the landscape is dominated by vast, soft mud plains. Few features break the monotony, and food is scarce, often drifting down as tiny fragments from above. The creatures that survive here have evolved to withstand constant cold and near starvation. Though the abyss seems barren, life continues in extraordinary forms. Finally, beyond 6,000 meters, we reach the Hadal Zone, a mysterious world found only in the deepest ocean trenches, like the Mariana. This extreme zone is shaped by tectonic forces as plates collide to form narrow, crushing chasms. Pressures are so intense that most machines struggle to operate, yet some organisms thrive. Small amphipods, snailfish, and hardy microbes live here, proving that life can endure, and even flourish, in places that seem utterly alien. And life isn't the only wonder hidden in these depths. What lies buried in the seafloor mud could completely reshape our understanding of Earth itself. Secrets buried in the seafloor. The seafloor, often imagined as a barren plain, is actually a vast archive of natural history and a stage for extraordinary processes. Its surface and hidden layers preserve the passage of life, the cycling of carbon, and the quiet endurance of ecosystems that thrive even in the darkest waters. One of the most fascinating features of the seafloor is the slow accumulation of material called marine snow. This snow isn't frozen water, but tiny fragments drifting endlessly from the surface. Every day, the ocean receives a shower of microscopic particles, the remains of plankton, the waste of fish, and sometimes even fragments of sharks that sink after death. What starts as organic matter near the surface gradually settles in the still depths, coating the bottom with a fine, soft mud. Over centuries, this layer thickens, holding a record of countless generations of marine life. The depth of this mud can be astonishing. In some areas, the sediment has built up to more than a kilometer, or about 3,000 feet. Layer upon layer forms a natural archive, much like tree rings or canyon strata. Each layer reveals clues about climate, ocean currents, and life's changes over thousands of years. Beyond serving as a record, these layers perform another critical role. They act as massive carbon sinks. Carbon once carried by living creatures becomes trapped in the deep mud, preventing it from quickly returning to the atmosphere. This slow burial helps regulate Earth's climate, giving the seafloor a role not just as a resting place, but as an active guardian of planetary balance. Among the most striking events hidden in the deep mud plains are whale falls. When a giant whale dies and drifts to the seafloor, it transforms the surrounding area in extraordinary ways. Though rare, the fall of a whale has a huge impact. What was once a barren stretch of sediment suddenly becomes alive, teeming with life drawn to feed and survive. First to arrive are large scavengers. Sharks, following the scent of decay, circle and tear at the flesh, while hagfish wriggle into cavities to feed on soft tissue. This initial wave strips much of the carcass, but it's only the beginning. Soon after, worms, snails, and other small creatures settle in, grazing across the surface. Colonies of bacteria thrive in the nutrient-rich environment, breaking down oils and fats within the bones and releasing chemicals that sustain entire communities. This process is not brief. A single whale fall can support life for years, sometimes even decades. Long after the flesh is gone, the skeleton continues to provide a foundation. Specialized species, rarely found elsewhere, depend on the bones for food and shelter. Tiny worms bore into the skeleton, while bacterial mats spread across remaining surfaces. Over time, the site evolves from an active feeding zone into a stable habitat, continuing to nurture life until every trace of the whale is fully absorbed back into the seafloor. What makes these falls truly captivating is how clearly they show nature's remarkable power to reuse and renew even the largest living beings. A whale, throughout its life, plays an essential role in ocean ecosystems through its feeding patterns and long migrations across vast waters. When it dies, its influence does not end. Instead, it continues to shape the environment, supporting an entire chain of life that would never survive in such barren, lightless depths. In this way, the death of one immense creature gives rise to countless smaller forms of life, strengthening the natural cycle that has kept the oceans alive and balanced for millions of years. Yet far below these delicate ecosystems, beyond where most life fades away, lies Challenger Deep, the deepest known point on Earth, and a destination for explorers driven by curiosity that reaches beyond science alone. Challenger Deep, where few have gone. The story of Challenger Deep begins in 1960, when Swiss oceanographer Jacques Piccard and United States Navy Lieutenant Don Walsh descended into its dark abyss aboard the bathyscaphe Trieste. This groundbreaking journey marked the very first time humans had ever reached such unimaginable depths beneath the ocean's surface. The Trieste was unlike any vessel created before it. Built with extremely thick walls and a heavy steel pressure sphere designed to survive the crushing force of the deep, their descent lasted nearly 5 hours. When they finally settled onto the soft, silty seafloor, they became the first humans to witness the deepest known location on the planet. Their time at the bottom was short, limited by the technology available at the time, but their success opened the door to an entirely new era of deep-sea exploration. For many decades after Piccard and Walsh's historic dive, Challenger Deep remained mostly untouched and unexplored. Its isolation and the extreme conditions made further missions incredibly difficult and rare. It wasn't until 2012 that the next major breakthrough occurred. Filmmaker and explorer James Cameron undertook a daring solo dive to the bottom in a custom-built submersible known as the Deep Sea Challenger. Unlike earlier expeditions, Cameron's vessel was outfitted with high-definition cameras and advanced sampling equipment, allowing him to document the seafloor in extraordinary detail. His dive captured both video footage and physical samples, providing scientists with valuable new material to study. Cameron's achievement stood out not only because of the advanced technology involved, but also because he made the journey alone, enduring the long descent and complete isolation in one of the harshest environments on Earth. The decade that followed brought renewed attention to Challenger Deep as explorers and engineers began developing new submersibles capable of making repeated journeys to extreme depths. Among them was American explorer Victor Vescovo, who piloted the Limiting Factor, a submersible specifically designed for multiple deep-sea dives. Beginning in the late 2000s, Vescovo completed several descents to Challenger Deep, each mission focused on collecting data, mapping the terrain, and gathering scientific samples. His expeditions went beyond symbolic achievement, transforming deep-sea exploration into a structured and ongoing research effort. Unlike earlier craft that could manage only a single risky dive, the Limiting Factor was built to withstand repeated missions, representing a major leap forward in deep ocean technology. Through these efforts, Challenger Deep shifted from being an almost unreachable mystery to a site of continued scientific study. Despite these advances, the challenges remained overwhelming. Every dive required years of preparation, enormous financial resources, and precisely engineered technology. At those depths, pressure is more than 1,000 times stronger than at the ocean's surface, meaning even the smallest design flaw could prove fatal. Because of this, visits to Challenger Deep continued to be rare and brief. Only a small number of people in all of human history had ever stood on its bottom, and every mission demanded careful planning and exceptional expertise. A new chapter began in 2020 when China completed its deepest dive to date using the submersible Fendouje. This mission marked the country's most ambitious step into deep-sea exploration. The submersible successfully reached Challenger Deep, carrying a crew that was able to conduct experiments and record detailed observations. For China, the dive represented both a scientific breakthrough and a powerful display of technological strength, showing that access to Earth's deepest waters was no longer limited to just a few nations. Together, these expeditions form a remarkable timeline of human determination and innovation. From Picard and Walsh's daring descent in 1960, to Cameron's bold solo mission, to Vescovo's methodical research dives, and finally to China's successful exploration with Fendouje, each chapter has pushed the limits of what humans can achieve. Every journey has revealed that Challenger Deep is more than a distant ocean trench. It is a proving ground for technology, endurance, and human curiosity. And unlike the one-time dives of the past, China isn't stopping here. What it plans to deploy next could permanently reshape who holds the keys to the ocean's deepest secrets. The rise of deep-sea robots. For centuries, the crushing depths of the ocean were believed to be unreachable, a realm far too hostile for humans to survive and far too complex for technology to overcome. A major turning point in this modern era arrived in 2020 when China's crewed submersible Fendouje successfully carried 3 aquanauts to the very bottom of the ocean. By 2024, China revealed an innovation that promised to completely reshape deep-sea exploration. Rather than depending on massive vehicles carrying human passengers, researchers began deploying shoebox-sized autonomous robots designed to operate entirely on their own. These machines were not connected to surface ships by cables. They were fully self-powered, equipped with internal energy systems capable of supporting missions that could last for hours or even days. This change marked a new way of thinking about exploration. The deep sea would no longer be approached through rare, high-risk dives, but through coordinated fleets of small, repeatable machines. Instead of launching a single vessel at enormous cost, dozens or even hundreds of robots could be sent down at once, each surveying a different area of the seafloor. The data they gathered could then be combined to create detailed maps of vast regions, something no single craft could ever accomplish alone. The design of these robots reflected the wide range of environments they were created to explore. Some were built to glide smoothly through the water, conserving energy as they traveled between survey locations. These gliders functioned like scouts, mapping large stretches of the ocean floor while sending back images and sensor data. Others were designed to crawl directly across the seabed, moving slowly and carefully as they examined sediment plains and collected samples. These crawlers offered close-up views of life in the abyss, revealing everything from tiny amphipods to microbial mats surviving in complete darkness. The advantages of robotic fleets went beyond their flexibility. Cost played a major role as well. Large crewed submersibles required massive investments to build and operate. Smaller robots, by comparison, could be produced at a much lower cost, making it possible to deploy many of them at the same time. If one robot failed or was lost, the mission could continue without disaster, unlike a crewed dive where failure could be catastrophic. This approach made deep-sea exploration safer, more resilient, and more sustainable, allowing missions to happen regularly instead of once every several decades. The emergence of these robotic systems also expanded access to deep-sea research. In the past, only the most powerful nations or wealthiest institutions could afford to explore the deepest trenches. With smaller and more affordable machines, universities and scientific organizations around the world gained the ability to participate. This spread of technology meant discoveries would no longer belong to a select few. but could become part of a truly global scientific effort. The data collected could advance research in climate science, geology, marine biology, and even guide decisions about sustainable resource use in the future. The success of these fleets depends greatly on how the robots are built. Each unit is constructed using materials that can withstand extreme pressure, often relying on titanium alloys and reinforced composites that resist collapse under the immense weight of the ocean. Their outer shells are smooth and rounded to reduce stress points, while internal compartments are protected by pressure-resistant housings that shield sensitive electronics. Power comes from advanced lithium batteries designed to operate reliably in freezing temperatures and sustain long missions without recharging. The robots are equipped with a wide range of sensors, cameras, and sampling tools, all carefully miniaturized to fit within compact designs. Their propulsion systems vary depending on purpose. Gliders adjust buoyancy to drift efficiently. Crawlers use mechanical legs or treads to move across the seabed, while flexible designs rely on articulated joints to slip into narrow spaces. Each robot also includes communication systems that allow it to upload data once it surfaces, or in some cases, transmit information acoustically through water. Building these machines demands expertise across robotics, marine engineering, and materials science, with every component rigorously tested before deployment. But what exactly are these machines searching for? The answer lies in resources that could either power humanity's future or place the planet at serious risk. What do you think about the growing race to control the deep sea? Will it drive meaningful progress and new discoveries? Or could it lead to irreversible damage to one of Earth's last untouched frontiers? Share your thoughts in the comments below. And if you enjoyed this exploration, don't forget to subscribe for more stories diving into the mysteries of our planet.